Okay, so we're going to the second question. What is the interval which graph is concave up? Okay, or the open interval, it could also be said. So I want to know, where is this graph concave up? So we all know, well, we have discussed that a graph at any particular point, the gradient is either increasing or decreasing, or the gradient is neither increasing or decreasing. Okay, so if I have a graph, something like that, so we have a cubic. So here, at this point here, if I have the angle of my pen, as I move along the graph, it starts quite steep and it's getting less steep. So the gradient along here is decreasing, and it's still decreasing at 0 now, so the gradient is negative. We have a stationary point. It's still decreasing until it hits a particular point here, where it has to start increasing again. Okay, it's increasing and increasing and increasing and increasing and keeps increasing. Okay, so where it's decreasing, this is concave down. Where it's increasing, it's concave up. Okay, so, and this point here where it changes, what's that called? Point of inflection. Point of inflection. Oh, an oblique. So this is an oblique point of inflection. Okay, we could also have a stationary point of inflection, which looks like this, where it's a point of inflection. So we're slowing down, slowing down, slowing down, slowing down, slowing down, and then we start speeding up. And the point where it changes is also a stationary point. So it's a stationary point of inflection. An oblique point of inflection is where it's not a stationary point. That's not anything you need to worry about, though.
So, yeah, do we need to know that?
The difference between oblique and stationary point of inflection?
Yeah.
No. 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 I mean, it's nice to know, but there's nowhere it's going to come up that's going to be super important. So I want to know where this graph is concave up. So it's concave up. How do we know if the gradient is decreasing? What does that mean? What's positive? The double derivative if it's increasing. Okay, so if we graph the derivative of this, okay, the rate of change of the gradient, so it's the rate of change of the rate of change, it tells us if it's concave up or concave down. So if y double dash is positive, okay, we're concave up, and if y double dash is negative, we're concave down. Okay, so that's the definition of it. That's what we can use as the definition. So we'll do question 2 here. Now, if it's not positive or negative, what does it have to be? A point of inflection. Okay, because it's 0. So this point here is when y double dash is 0, then we have a point of inflection. Okay, so I have my graph here now. I've got my original graph. Now I'm also going to find my double derivative straight away, so that's 24x take 36x squared. Okay, so what I need to do is I need to find my points of inflection first. Okay, so I'm going to find my points of inflection, and I do that by letting the double derivative equal 0. So I have 0 is equal to 24x take 36x squared. And again, what can I do to find these points? To solve this, that's right, I factorize. I mean, you could use the quadratic formula here with c is equal to 0, but that would be... I'm going to take 12 out as well. So 12x outside of, I've got 2 take 3x. So these two things are equal to 0. So I have 12x equals 0, which means x is equal to 0. And I have to take 3x is equal to 0. So that means that x is equal to 2 on 3. Okay, so these are my points of inflection. So the graph, we haven't done this sketch, but I'm happy to give you the sketch. It looks something like this. Okay, so remember we had a stationary point at 0, 0. So this is one of our points of inflection. And we had a turning point at 1, 1. Didn't we? Yep, at x1, y1. And so we have these 3 intervals. So if we, no, we don't. So we have a point of inflection here as well. So if this is 1, 1, that's when x equals 2 on 3. Oops, 2 on 3, not the... No, so we've done sketching. This is me giving you the graph so you can see it. Okay, this isn't us sketching it now. So we have this, you can see if you put in where x is 2 on 3, which is here, it'll be between 0 and 1. Okay, we have a point of inflection here. So what we need to be able to do is to split our graph into its intervals. Where is it concave up and where is it concave down? Okay? Now it's going to, we really have 3 intervals. Okay? I'm going to split it up with my points of inflection as the points on the intervals. So I'm going to create 3 intervals, A, B, and C. So I'm going to let A be the interval where x is less than 0. So A is this area beyond the first point of inflection. B is going to be the interval where x is between 0 and 2/3. And C is going to be the interval where x is greater than 2/3. So this area in between here, that's B, and the area greater than there is C. Okay, so to work out whether it's concave up or down, I need to take a point from each of these intervals and substitute it into my double derivative. And remember, if my double derivative is positive, it's concave up. If it's negative, it's concave down. It won't be 0 because I've already got my points that are 0, which are the bounds. So I'm not going to use the actual points of inflection in this. So what's the point in A? So I'll test this. What's the point in A? -1. Okay, so I'd always like to pick a nice, round, easy point. So let's let x equal -1. This is testing A. Y double dash, that's y double dash, it's 24 by -1, take 36 by -1 squared. That's -24, take 36, that's -60. So that's obviously negative, which means it's concave down. You can use those up and down U's as well to say concave up or down. Let's do B. What number could I pick in B? Could pick a half, that's going to be probably the easiest one. Let x equal a half. Y double dash is 24 times a half. Take 36 times a half squared. So that's 12 take, what's a quarter of 36? That would be 9. 12 take 9 would be 3, so 3. So that's positive, so I have what? Concave up. And then C, we found concave up. But let's just do C as well. What number could we use for C? Let x equal 1. 1's in C. So C is from that point there. So x equal 1, so y double dash is 24 by 1, take 36 by 1 squared, which is negative 12. So that is